There's getting to be fewer and fewer parts of this to make. There's really only this frame, the slide bearing caps, and the connecting rod and crank pins to go. So I want to preserve that spreader there, stretcher, that piece. I want to preserve that as much as possible, so I'll be drilling the hole in the end on the lathe. And I'll have to mill away half of this to get a flat surface there, and a similarly flat surface there. So pretty much going to be holding it on that strap, both in the lathe and in the milling machine. This is supposed to be 3/4 wide, and because both pieces are off centre, misaligned with each other, it's not going to be 19mm wide diameter. It's going to be considerably less, but the centre of this hole not so much has to line up with this boss. The centre of that hole has got to be just below that surface there, to give me an opportunity to mill some of that surface away to make it flat. If I drilled it just on centre there, then to get a clean surface on that flat blade bearing area, I would have to go below centre on the hole. Not to be done. So probably get the compound slide off of the lathe and somehow clamp this down straight to the saddle cross slide. Now, as luck would have it, just one 75mm 25, 50, 75 block on its side puts this at just the right height that I want it at, which is putting the centre of that boss just above centre. It's good enough anyway, it's going to give me a start. So when I drill that hole, the centre line of that hole is going to be just below this surface, allowing me to mill off some of that surface when I take half this boss away. What's going on here is using that rib as the reference straight surface for the whole frame. I've clamped a parallel to it, and just by feel adjusted that parallel to be parallel with the rib, and then put an indicator on the side of that parallel, which brings that rib in line or parallel to the centre line of the bed. So all I've got to do now is shift this from one side or the other, get it sort of approximately in the middle, put drill bits and whatnot in the chuck end of it, drill some holes. Alright, so I want to drill this hole 42mm deep. That's the depth that I've decided I want to drill it. There isn't a dimension on the drawing, so I can't trust the hand wheel on this carriage. You try and travel it 20mm and it's actually travelled something like 19.7, so it's only good for rough guesses. So to set this to drill exactly 42mm deep, I've got a 42mm gauge block stack, and if I stack that between the carriage stop and the saddle, there we go, it's still there. So what I've got there is a 42mm gap. A bit more precisely than it really needs to be, but what choice have you got? So all I need to do is to drill this hole until the carriage comes up against the stop. The stop does have a ball bearing in it to give it a good solid register on there. Now I don't need to drill 42mm deep with this drill, this is just to get it started, but it'd be the same method for all the other ones. Every time I take a drill out of the chuck, put a new one in, I'm going to have to repeat this gapping exercise, but that's the way it's done. Stand corrected on there not being a dimension for the depth of this hole. There is, it says 1 3/8, about 35mm. What there isn't a dimension for is the length of this boss here. Now I'm going to keep it as long as it can be. I'm just going to, when I get it in the mill, I'll just face that off, get it parallel, and make the screw the right length to accommodate for that. There's no reason to make this shorter than necessary, but it's another case of missing dimensions on the drawing. Same trick again with the 42mm gap. This will open it out to 9.5mm with a rather snazzy looking drill there. And there it is up against the stock. Just remains to ream it to 10mm. Clamping this frame on the same cast rib. It's a bit of a dodgy clamping setup, but there it is, and lining it up on the same parallel that was left clamped onto the rib there, so that drilled hole is going to be in line with all of this as I mill it around. I think for now what I'm going to do is clean off this end, clean off that boss, mill that boss down and mill off this face here. That boss and that face needs to be the same height as well. But just establish kind of reference surfaces and things. I won't be drilling any holes in anything yet, because that needs another double check and measure up. Much of this is going to come off kind of freehand, with the exception of the extent down to here. I've got a table stop on that, so that I'll leave this boss on the end in line with this edge. It's going to need some filing work and everything else when it's finished. It's such a mess. And I'll also take it down so that this is cleaned up to a good extent. I've got the head so high and the quill sticking out so far and the mill cutter sticking out so far because I want to be able to just lift it up and come back and do the other end, so that the geometry at both ends pretty much matches. Right, let's get going. Now that I've exposed that hole, there is an important thing I have to deal with. I want this to come down exactly to the centre line of that pin. So what I'm going to do is set the zero of this cutter onto the top of that pin, and then bring it down 5 more millimeters. So here we have a 0.1 feeler. Right, so that is 0.1 of a millimeter off of that cutter, that pin. Zero this, bring it down by 0.1. Zero that again, and now I need to come down 5mm more than that. Okay, so that is that's exactly halfway down on that. So if I turn it so the flutes so the cutting edge is horizontal, that is exactly halfway down that bore. So this is down on 5. If I actually zero that, I'll be able to come back down to 0. I want to bring the y-axis back to 0 on that edge there. Lock that. This way I can repeat the depth and the edge on this other end up here, just by lifting this out of the way, coming across all the way over to this other end. So I see there how much I've got to go. I've only got 1mm to go, so I might as well zero it and take the whole lot off in one hit. With the frame resting upon these 1, 2, 3 blocks on the machined surfaces that will eventually take the blade and tensioning paraphernalia, it's clamped down on those surfaces. This end of the frame it's going to wave about, that's sitting up on an adjustable parallel, which is clamped down as well. This is still going to be a bit floppy, but not too much. It's very soft material, and I can always take. I've not got to take much off it anyway. Been hesitating a lot on how to machine this in the proper dimensions with proper references. What I've settled on is lining up this pin here with this feature that will take one of the threaded holes. So that's pretty much got this spindle centered on that circular feature there, and what I'm going to do is drill and ream a small 4mm hole in that, and then I'm going to travel the table up and drill and ream a 4mm hole in this one, and those two holes will be my references for the future. That way I can keep coming back to them to machine this vertical face here. When I eventually need to drill the holes at 50mm distance, I can line up on that pin again, go over, drill that hole in that end, and the same on this end. So the whole thought here has been, what can I reference on? Make 2 holes, put 2 pins in, and reference on those. I just turned up a little brass pin there that's a good snug fit in that hole. Doesn't matter what size it is, it's to centre up upon. So I'm going to travel the table along and drill another 4mm hole in that end as well, and these will be my 2 reference holes for the rest of the machining. .4.1, good enough. So I want to come back to that 0 when I cut the other half at the other end. One, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I do have another 2 to travel in to bring that face down to the same place as that one. 4408. This end was 44.1. So there's the parallel that I've measured at 4.07 thick. Put it on there so it stays on there. And this is measuring 8.66. 8.66 plus 4.07, 12.73. 12.73, and I wanted it 12.7, so that's a very small amount over ½ inch, very small amount over the thickness of the bar. The height of this feature is the most critical part about the slide. That's all these runners machined. All the holes have had the beginnings of being tapped out. I'll do that by hand when I get it out the machine. But using like a tooling pin like that in reference holes to keep coming back to where your reference positions were, that was a godsend. That way I could never lose my way as to where I was. So turn down a little pin out of a bit of scrap, and now I've got a smaller piece of scrap to go back in the scrap bin. This is the casting for the sliding bearing caps. I'm measuring these in the same way using that tooling pin. So these are the 2 caps put together with a couple of 6mm drills through the holes. So they are a mirror image of each other. 0 on that drill. Come down another 0.1 to take care of the feeler gauge. Okay, 0 that. Now I want to come up by 22 millimeters. That will then put the centre of that hole 25 millimeters off of the edge I'm going to machine there. The whole piece will end up being 2 inches wide. Right, so if I just 0 that, then I can come down to it in gentle cuts, because it's not particularly strongly held in the vise as per usual. So now with these slider bearing caps put on, all the screw holes lined up, got a funny selection of screws that are supplied here, but never mind, they're all kinds of lengths. This has got like a little bit of wobble on the back there, virtually none on the front. But what's most pleasing is that it's a good smooth slide with a very tiny bit of drag on it for running in purposes. I don't think that's dragging enough to actually seize or anything like that, but give it a little run in session, some light oil, and it'll be okay. But I'm just checking through that a blade will actually fit within all of these dimensions, and that's resulted in some considerable dimension changes to this draw bolt here. So I'm going to make the draw bolt a little bit shorter. There's no need for it to be over long, and I'm going to make a much longer thread on it as well, so that the thread comes halfway down this boss. I'm still pondering how to make this pin in here. I'm thinking of drilling that from the back at an angle to emerge in the right place on this side, and then I can use something like an M4 Allen screw that's turned down to like a dog tooth end to act as the pin in here. I don't really want to be pressing or pushing or Loctiting a pin into this soft aluminium casting, because over time it will just loosen up. The other thing, they give you a piece of 1.25 inch bar. It's a bar that's actually shorter than it is wide, to make the tensioning nut out of. So I'll not be making it out of that piece of bar. I've got a piece of 1 inch that's a bit longer, something you can get hold of, so I'll have that in the chuck of the steady rest and make it on this end. Fraught with danger, this is. It's so close to coming off. Making the noises. There we go. That was emotional. Now, because I know it's at an angle and it's only a 3mm hole I'm going to drill, whatever tool I use is going to be flexible, so I'm going to come in here as fast as the mill will go and just establish the beginnings of a hole, then swap out and change it to a drill. See, it's only took like half a cut there. If it was a drill, it would have wandered off downhill. It's made a flat on it anyway, and something like this, and yeah, it's got a nice little angle on that, not much, just enough. Then I'll braze that in a few moments. This bore is now on the centre line, and I want to make that outer diameter concentric with that bore. Be nice to bring it down to 18mm as well, and that will match the 18mm of this, and things will look nice. The idea here, that's a boring head, obviously, and if I run it backwards, and if I have the cutting tip of the tool facing inwards, I should be able to stroke it down the outside of that that boss there. And this is going to bounce around like a springboard, but I'll take gentle tiny cuts as usual. Gradually adjust it inwards, bring this down to 18mm. So after all that, there's the rounded off boss, same diameter, centered up on the screw. Looks like it should do. Bit of a blemish on the back there where it hasn't cleaned off all the casting, but there's nothing I can do about that. That's the way it's cast. That's all gone. There's the frame on the slide bar. Just got the connecting rod and pins to go. There's one thing though, another design thing. The blade doesn't actually come below the bottom of the vice bolster, so anything that is rested upon that surface there, it's not going to cut it all the way through. This is to do with this linkage at the back here. That is a given length, and that is what stops the whole contraption coming down. I've reduced the length of this piece of linkage down at the bottom there by about 4mm, so it does still bottom out on that linkage, but to do that I had to increase the length of this slot by another 4mm. There is just about some clearance, possibly 1mm up the top of the cylinder here, so all of this is about as short as this is going to get. The blade now does become below the bolster height. There's not a lot of margin in this, you know. You might find yourself making all these parts and then you're up there somewhere and it's just not going to cut the metal off. You're just going to leave it and it's just going to sit there switching itself off without finishing a cut. It's as good as it's going to get right now though.